Hello. So today I didn't really make much progress, sadly, but I have a little report to make with some interesting stuff. So I was going to get around implementing the whole animated model for animated level parts export and import system, right? So as I mentioned, we can already go ahead and unpack an entire XMB file from the base game and read all of the data, right? And the objective would be to add support for the animated level parts, even if they don't have animation yet, on the exporter side on Blender, right? So that we can add interactable objects, since those are, as I mentioned in a previous video, animated level parts. But a small problem came up, and that was the fact that in Magicka, the system that the XMB files use is kind of weird, because the base XNA model, which is the one that is used for the animated level part, uses a property which contains an index that points to a shared resource, which is where the material is located. Materials being effects, as they are named in XNA framework, right? It points to the effect used by that model, right? And every single part that uses a different material, it has a list of where it begins in the vertices within the index buffer, right? And it points to the index of the shared resource that it uses. The problem is that the base game models used for regular environments, right? The non-animated models, those in specific, do not use that system. They use, as I explained in some of the first videos, completely inline materials. And since they are completely inline, that means that I'm going to have to rework the exporter system to work with inline materials for non-animated level parts and shared resource pointers for the animated level part. So the problem comes from the fact that since the first part that I reverse engineered was the regular non-animated level parts, I did not have into account, because I didn't know how it actually works yet, right? I had not checked the way that XNA models worked at the time, so I didn't really add proper support for shared resources, and I initially thought that I would just have a different resource, like in different JSON files, so have a primary object within one JSON file, share resource within another JSON file, etc. Right? And you could just have something like MagickaPUP pack, and then you would put in the name files, and the first would be the primary object and the others would be shared resources. But that doesn't really seem like a great idea to me, right? So because for extracting the XMB files, you would have to generate multiple JSON files, and in Blender, when exporting, you would not really have as much freedom, because you would have to put one name for your main primary object JSON file for the entire map, and then another one for each shared resource, which would only contain a copied version of your materials. It just didn't make much sense, right? So I decided to rework the format. And now you might be reading this thing all this time, which may look kind of weird if you've paid attention in the previous videos, which is the primary object directive, right? So if I close this right here, you can see that my JSON files now have this structure. They contain an object, which is the primary object, and within this object there's the entire level. Just as the thing that is contained within primary level is what our old format was like, so everything in here was the only thing that we had before, and then now we have a number of shared resources and a list with the shared resources, right? And you can open them up, and they are pretty much just effects in this case, because they are the only shared resources that this contains as of now, right? So that's it. That's all I can really say for now, because that's what has been changed, right? So if we go over to the old file, okay, all right, so I open the old file. Here it is named conveniently old version. So this one right here, as you can see, it's a single object in the entire file, and this right here is already type model blah blah blah. All of the stuff from the primary object, which if we go back here, we open it up, we can see that this object right here, well, it's what we have in here. This does not contain any shared resources in the old version. So as I said, shared resources, which we're gonna see once again, just for clarity, rather than being within a list, they would be, rather than having a number of shared resources, we would have those as separate files. So this would go into its own file, and obviously this would, like, it's not necessarily a better or worse system when it comes to bloat, because we're already duplicating information that we could have within one single file, sadly, due to the way that the XMB file format works, right? But the thing is that before we would have a lot of duplicated files that, for example, we could say, imagine my level is named map.json when I export it from Blender, and I would have to compromise on naming it map.json or something like map underscore shared resource 0.json, map underscore shared resource 1 JSON, blah blah blah, right? And that's a bad idea, because you may obviously make a map named map JSON share resource 0.json and export it, or just have a file name like that. So a user could purposefully, you know, make another file, put whatever inside, and if it has the same name, it would be completely obliterated by the exporter, right? And if you reduce the number of you know, files that you now have to, of shared resources, by changing your map, pretty much, you now have to worry about the fact that you have to deal with packing extra shared resources and breaking your index, you know, the indices for your shared resources, for putting in the wrong files when you actually pack things together, because the exporter from Blender has to know at export time what the indices are going to be in the file, right? So we would have a lot of problems having to deal with multiple files, and it's far easier, because if you remove something and you forget checking the dates, you could have another file that you accidentally pack together, and you've now broken your index mapping, right? So your indices are now completely destroyed, and that's not good. I mean, there are situations where you would just have an extra resource and it may not be broken, but if you make use of all of the features that the map can have, then you indeed would probably break everything. So from a certain point on the level, right, like maybe the first 5 shared resources are okay or whatever. So to avoid all of these problems of packaging extra data, which we could actually just make it so that the extra resources are completely on the end, so you don't break anything, but you only bloat further your file, I decided to just have a whole shared resources section to the file, and this is what the files look like. So my previous files are no longer exactly compatible with this, but that's okay, because they don't need to be. It's just previous testing, right? Like, we can deal with these updates very easily by changing the exporter. So yeah. And of course, if anyone ever needed to do a little bit of manual patchwork with any breaking changes of what I've made, because this update obviously is breaking with this small change, if anyone were to have to do so, because I haven't really published my tools yet, since they are not public, there really isn't anyone on planet Earth that requires doing any kind of patchwork. But if that were the case, it would be as simple as just imagine having your object be something like this, right? You have your, you know, your type, level, model, or whatever that is, etc., right? That would be your object, and this is what your file would originally look like, and you could just go ahead and wrap everything up, and you would have a primary object, num shared resources, and then you could just put in your shared resources, right? And this would be your new file. A little bit more convoluted, I guess, has extra stuff. Obviously, this would be the fix, because my old objects exported from Blender did not have any way to have shared resources, because there was no feature of those that were supported that required shared resources. So that would be the simplest way to patch up everything. And this is literally just copy pasting your old file in here, or just, you know, writing around it, however you prefer. So yeah, it's pretty easy to fix change, to be honest, and hopefully any future breaking changes that I make would be on this same level of easy to fix, right? And of course, I want to also talk about other changes that I'm going to make, which is the following. We have a small problem which someone may have noticed before, probably nobody. I just noticed today. So the problem is that when I read my animated level parts, right, I have a function that reads, you know, the whole set of bones, the tag names, etc. And then I go ahead and read the vertex declarations, and the vertex declarations have a number of entries, and each entry has its own vertex declaration, right? And you could have multiple vertex declarations depending on how many parts your mesh would have and how many of those will have different declarations. But in my case, I most likely will use the exact same declaration for everything in my exporter. So yeah, if you want different ones, you'll have to write them by hand until I decide that it's worth it to add support for different declaration types. So after that, we have the number of model meshes that are contained within it, and our model meshes have its bounding sphere, etc. And we have we have a vertex buffer, and the vertex buffer right here contains all of the bytes of the vertices that are contained within the object, right? And we have the index buffer. As of now, nothing weird, nothing bad, nothing wrong, everything is correct. But after that, we have our mesh parts, and the mesh parts, every single one of them contains an stream offset, right? A base vertex and a number of vertices, start index, and a primitive count. And this is what tells us every single part what is it that this part contains. And what I mean by that is that they would look into the vertex buffer and say, I start from the vertex buffer with an offset 0. I start at index 0 for the indices of, you know, for the index buffer, right? My base vertex is going to be vertex 0, and the number of vertices that I have that I'm going to be reading is going to be this one right here. So we go over to our vertex buffer, we got this many bytes, right? And we go over to our vertex declaration. We can see that our vertex declaration has got this structure. So you could just divide it, and you would see that it would be corresponding to the number of vertices, right? And whoops, that is not what I wanted to close. So and here is the number of triangles that you will have in the end. So if we go over to our index buffer, we have index size 0, which doesn't mean there are 0 indices. It's, remember, 16 bits. And if we look at this list right here, with the number of bytes being 204, and we know that they are 16-bit each, which is 2 bytes, so we got 200 for, you know, obviously a half is going to be 102, and since we know that each primitive is a triangle, we can go ahead and divide that up, right? We can see that if we divide 102 by 3, we get 34. So we pretty much have the correct number of primitives in here. So in this situation, this mesh part right here contains the entire model. But you can have multiple parts, which will be, you know, these parts only exist for the purpose of assigning different materials to different parts of the model, right? So if your single model has only one material, you would only have one mesh part. Every single mesh part is literally just a way to represent that you've got your buffer of vertices and indices, which is your entire mesh data, and what part from what vertex to what vertex, from what triangle to what triangle are you going to be assigning this material to, right? So obviously this is a problem, because if we have in the same buffer multiple areas with the same material, there are multiple materials, we will have to instantiate each of those either as a different material or as the same material but different mesh parts pointing to the same shared resource. So that's a problem that I'll need to figure out for the exporter, right? And the problem here is that this data, as you may have noticed, has the vertex buffer duplicated, index buffer duplicated and the vertex declaration duplicated. Why? Because I was reading the code from the decompile Magicka code, which is what they do. They copy this data and assign it to this part to work with. They don't exactly copy. They take a reference to this object. The problem is that for us, we don't care about this reference because this reference only exists as a pointer in memory inside of the game. And obviously we cannot have a pointer to that during file creation time, at compile time, let's just call it, right? Because these values are generated during runtime. So what we should have instead to create the proper files should be an index or something, right? Like the vertex buffer and the index buffer doesn't need to exist between mesh parts on the MagickaPUP program, and the vertex declaration, rather than being itself a copy of the vertex declaration, should be a value, an index, right? Vertex declaration index, which would point to what vertex declaration out of these ones are we using, because we already have all of this data right here, and the rest would be done automatically by Magicka. So that is a small problem that needs to be solved, and it's very easy to change. Obviously it needs restructuring of the code. And after applying the fix in the code, we can see that over here the generated code now only contains within the model meshes on each model mesh one vertex buffer and one index buffer, and this information is no longer replicated in here. We don't have duplicate information within each mesh part, and the mesh part no longer duplicates the vertex declaration and now contains a vertex declaration index property. So yeah, that's all it really needs to have. So another thing you may have noticed would be that tags contain always null, and I've been investigating, and it appears that in Magicka pretty much almost all the maps, I say almost because I haven't checked every single map, but I have not I haven't found a single map where the tag is not null. I have looked online what the tag does, since this is XNA specific model information. It's not actually specific to the way Magicka does things, right? And the tag is pretty much free for use for whatever you want. The tag contains any object that the creator of the mesh would want it to contain, with any information that could be used somehow. Some of the information may contain weights information, but I am not sure how that would be used, since there is no examples of what the data may look like within Magicka's code. So yeah, for now the exporter is probably going to always export this as null for a long time, until I figure out what this could be used for eventually. I just need some more time to reverse engineer what this information is actually utilized for under the hood, but yeah, that's all I can really say about this. And yeah, I know that this was a pretty underwhelming video and there wasn't much to show. It was just commentary on the code, but I think it still has some value to document this in some way to get feedback, although there's probably absolutely no one interested in watching this. But yeah, I mean, as of now, after having reworked the JSON format and having actually added support for shared resources, right, should be pretty easy to actually implement the actual model export stuff in Blender. I just want to get a few details down, because I'm not completely sure how each bone is assigned to each part of geometry, so I will need to export a bunch of examples. But I will close this video on a note saying that I have been checking out the effect data, right? And this is probably the next thing I'm going to actually implement in the exporter, apart from the fix-ups required for shared resources, because it seems like making the shared resources, I didn't mean to say that. I meant to say it seems like making the effects, right, is going to be pretty trivial actually, because if we look at this, right, the reason I got mistaken saying share resources is because I was getting ahead of myself, and I wanted to mention that if we look at the way that effects are made, these effects referring to particle systems probably, and not materials, right? I know it's kind of weird that the framework calls both the same, but well, I mean, XNA framework effects are materials, and Magicka effects are both the XNA framework effects, right? And the effects, they also use that name to refer to the particle system in game. So yeah, it's kind of weird why they would name both the same, kind of confusing, but this effects refers to particle effects, and if we look at them, they have some IDs for some reason, which I suppose we could just export as the name of the object itself, right? And I am not completely sure why they would be used. Probably if we make them movable later on in animated level parts, that could be the reason, right? And they contain two vectors, which to me look like a position and a rotation, but a rotation, if you look at this value right here, it might be familiar to anyone who's done a little bit of math regarding geometry. So these clearly are not in you know, degrees. These are rotations that are you know, in radians. So yeah, I'm not sure why in Magicka they mix up a lot of things. They named this vector 1 and vector 2 in the decompiled code, so probably these were literally just properties that were directly read, and in the decompiler it translates them to two different variables. So at least now we know what they do, and we can rename them to position and rotation rather than vector 1 and vector 2, right? The range, I don't know what it exactly does, right? But anyway, it's kind of weird how some rotations use Euler angles, you know, even though they are, you know, in radians rather than degrees. That's okay, it's still an Euler angle because it's got X, Y, Z components. But other parts of the code use quaternions, right? And I'm not entirely sure why they would mix those up, especially when there are parts that are not exactly like, you know, XNA framework specific stuff versus Magicka specific stuff. Like this inconsistency is found within Magicka specific stuff for some reason, right? I guess it was for ease of implementation or whatever, and some other things use rotation matrices, right? Like it's kind of inconsistent. I would like it if everything would use probably Euler angles for the sake of allowing people to modify these values by hand in the JSON file easily, but I'm gonna keep it the way that it is for consistency with the code and ease of exporting data from Blender, right? But anyway, what I wanted to say is that these names right here, if you look them up, they are not in the shared resources of this file. So whatever they are located somewhere else, probably in some folder within the game's data that, you know, contains stuff related to particles. So that's what I'll be working on for the next video, basically. So yeah, there's not much else for me to talk about on this video, and once I get done with the whole particle system stuff, if I can get it to be working, I will finally get on with the animated level part, which is probably what's gonna take the most amount of work, because it's kind of, you know, I mean, we'll have to deal with animation data and everything even if we don't want to, so that's annoying as fuck, and it's going to be kind of complicated. But yeah,